So I want to write these formulas in each of the ionic compounds. I have barium and iodine, and one of the things you need to do first is look up their oxidation numbers. The way you look it up is you basically just go down to this periodic table. Barium's right over here, and he has two valence electrons. So he's going to want to give up those electrons. So barium's going to create a positive 2 kind of deal, whereas iodine, on the other hand, is going to create a negative 1 because this iodine has 7 valence electrons, and so iodine desperately wants to grab one extra electron. And when iodine does grab that extra electron, he's going to have a negative 1 oxidation number. Now, they have this thing called the crisscross rule or something like that, where basically you just kind of crisscross like this. And I really hate learning those kinds of tricks, mainly because it doesn't always work. What happens if you have 3 elements? Then you can't really crisscross anything. But in this particular case, I mean, the way I guess I look at it is, well, we have barium, which is a positive 2, and we have iodine, which is a negative 1. How many iodines will we need to match up with that one barium? Well, that's pretty straightforward. You're going to need 2 iodines for every 1 barium. So barium and iodine combined looks like BaI2. That one's pretty straightforward. All right, calcium and oxygen. Let's do that one. We've already done oxygen. Oxygen has a negative 2 ionization or oxidation number, and calcium, let's see. Calcium has a positive 2 because it's in group number 2. It has 2 valence electrons. It's going to want to get rid of those 2 valence electrons, and when it gets rid of those 2 valence electrons, it's going to have a 2 more protons than it does have electrons. So I guess you could use the crisscross method, and you go, okay, well, this is Ca2O2. Basically, you take this number here and you put it here, and then this one here and put it there. But in all honesty, I mean, just look at this. Like, calcium has a positive 2 charge. It wants to balance out with the oxygen. How many oxygens do I need to balance out with that one calcium? I actually only need 1. So without using the crisscross method, I basically just said, well, I can just write it down. And honestly, this is the right answer. This technically is correct, although it's not in the simplest reduced form. You could divide everything by 2, and that's kind of what they like to do. So I really don't like that idea of the crisscross method. I guess you guys can use it for now, but really understand where this stuff comes from, because it's actually not that hard to kind of just write these down if you ask yourself, well, how many iodines do I need to balance out with the barium, or how many oxygens do I need to balance out with the calcium?